Well, hello, statistics students. Hey, just one brief set of notes remaining. Previous notes were on statistical testing, but there's one kind of testing that I did not cover in that set of notes, and it's called chi-squared testing. So careful, this is not chi or chai, it's chi-squared testing. Chi is a Greek letter, chi-squared testing. And it's used when we have data that's not really data you can find an average of or a proportion of, like this data I show here. So it says that analysts wanted to see if consumers have any preference of 5 flavors of a new soda. And there's 5 different choices, and essentially this survey was given to 100 people. They were asked to pick their favorite, and the results are as you see them. Now here's the deal. It appears right away that, hey, cherry and strawberry are the favorites, so let's just go with it. However, anytime you collect random data, like for example, if you roll a die 100 times, there's going to be one of those categories or 2 of those categories that appear more often than the others. Not because they're preferred, but because that's just how random chance works. So chi-square testing, as far as it's seeing, is this distribution of data different than what we would expect just by random chance? Okay, so to do chi-square testing, there are 4 steps. First step, you need to state the hypotheses. Now here's one nice thing about chi-square testing. The hypotheses are always the same. You don't have to use any special symbols. You don't change it based on the problem. So you just say, hey, the null hypothesis is that variation is caused by chance. The alternate hypothesis is that there is variation, that what we saw on the previous page varied more than what we'd anticipate based on chance. Okay, now unfortunately we can't do chi-square testing with our graphing calculators. There are some that can, but a lot can't. We're going to do this by hand. It's not that bad. Bear with me, you'll be okay. So our second step is to compute chi-squared. Okay, and here's the formula for it. And it looks much worse than it is. So to compute chi-squared, let me just point out what this formula is saying. This is the symbol for summation, meaning we're going to add up a list of numbers. We're going to take O minus E and square that and divide by E. Well, what do those mean? Well, O is our observed values. So those numbers on the previous page, those 5 numbers, each of those is a value of O. E is what we expected to happen. Now, if everything was distributed perfectly evenly, we expect the average of those 5 numbers to be what was picked in each category. So let's just take a look back at the previous page. If you add those 5 numbers, you get 100. Divide by 5, we get 20. So E in this case is 20. Okay, so let's go back to that formula. Here's what we're going to do. We're going to take the values that actually happen, the O, subtract what we expect, which is 20, square those answers, divide by 20. We'll do that 5 times and then add what we get. Okay, I'm going to go to my original data. So let's see here. So with that number 32, first thing we do is we take observed minus expected, 32 minus 20, square that value, and then divide by 20. Well, that gives us 12 squared over 20, which is saying 144 over 20, which is a value of 7.2. So that's our calculation for each of these. So for the next one, we do the same thing. 28 minus 20 squared divided by 20. Well, that's the same as 8 squared over 20, which is 64 over 20, which is equal to 3.2. We do the same for the next one. 16 minus 20 squared. Careful with this one. 16 minus 20 is negative 4. We square that, we get a positive 16/20 or 0.08. And in fact, because we're squaring, all of these numbers will always be positive. If we plug 14 in there, 14 minus 20 squared, we get negative 6 squared over 20, or 36 over 20, or 1.8. And we do that same calculation for that last number, and we get a value of 5. Now, our chi-squared result is what we get when we add all of these together. So if we add these 5 numbers, we get a value of 18. That's our chi-squared statistic. Okay, so let's go back to those 4 steps. First step, state the hypotheses. Remember, those are always the same. Second step, we just did that. We computed this. We got a value, once we added everything together, of 18. Okay, I'm going to scroll down here. Third step. Third step says compare this value to the table on page 234. Well, if you had your textbook handy, you'd look up that table, you'd find what you need. Since you're watching this, you probably don't have your textbook handy, so I gave you part of the table. N is the number of categories you had. Like on the previous page, there were 5 flavors. This is our chi-squared statistic. So here's the deal. And I gave you a bunch of them because in the tests you're going to have, in the reviews you're going to see different N values and different values here. Let's get to our conclusion. If what you calculate is greater than the table value, you reject the null hypothesis. So the table value kind of gives the limit, the cutoff value. Anything bigger than this value means that we have more variation than what we'd expect by chance. If the calculated value is less than the table value, do not reject the null hypothesis. Well, keep in mind what we saw. We got a calculated value of 18. The table value in this case is 9.488. Whoops, why did I write it this way? 18 is definitely more than that table value. So in this case, we're going to reject the null hypothesis. So here's what that means. It means we have enough evidence to say that, if I go back to the null hypothesis, that variation is caused by chance. So with this data that we started with, variation is definitely more than what is caused by chance. So we can conclude that people have a definite preference for these soda flavors, and it looks like cherry and strawberry are preferred. So just a review of the 4 steps of chi-squared testing. State the hypotheses. The nice thing is they're always the same. Compute your chi-squared statistic. It's a little tedious, but it's not too bad. Take a look at what you have compared to what's in the table. And if what you have is greater than the table, like we had, reject H sub O. If it's less than what's in the table, do not reject H sub O. All right, ladies and gentlemen, that's the last kind of problem you need to know. So dig in, see what you can do, and please check in with me if and when you have any questions. All right, thanks. Have a great day.